we're asked to determine the solution set of this system. And we actually have three inequalities right here. And a good place to start is just to graph the solution sets for each of these inequalities, and then see where they overlap. And that's the region of the xy coordinate plane that will satisfy all of them. So let's first graph, well, let's just graph y is equal to 2x plus 1. And then that includes this line, and then it's all the points greater than that as well. So the y-intercept right here is 1. If x is 0, y is 1. And the slope is 2. If we move forward in the x direction 1, we move up 2. If we move forward 2, we'll move up 4. Just like that. So this graph is going to look something like this. Let me graph a couple of more points here, just so that I make sure that I'm drawing it reasonably accurately. So it would look something like this. It looks something like that. That's the graph of y is equal to 2x plus 1. Now, for y is greater than or equal, or if it's equal or greater than, so we have to put all the region above this. For any x, 2x plus 1 will be right on that line. But all the y's greater than that are also valid. So the solution set of that first equation is all of this area up here, all of the area above the line, including the line, because it's greater than or equal to. So that's this first inequality right there. Now let's do the second inequality. The second inequality is y is less than 2x minus 5. So if we were to graph 2x minus 5, and something already might jump out at you, that these two are parallel to each other. They have the same slope. So 2x minus 5, y-intercept is negative 5. X is 0, y is negative 1, negative 2, negative 3, negative 4, negative 5. Slope is 2 again. And this is only less than, strictly less than. So we're not going to actually include the line. The slope is 2. The slope is 2. So it'll look something like that. It has the exact same slope as this other line. Slope is 2. So I could draw a bit of a dotted line here if you like. And we're not going to include the dotted line, because we're strictly less than. So the solution set for this second inequality is going to be all of the area below the line, right? For any x, this is 2x minus 5. And we care about the y's that are less than that. So let me shade that in. So before we even get to this last inequality, in order for there to be something that satisfies both of these inequalities, it has to be in both of their solution sets. But as you can see, their solution sets are completely non-overlapping. There's no point on the xy plane that is in both of these solution sets. They're separated by this kind of no man's land between these two parallel lines. So there is actually no solution set. It's actually the null set. There's the empty set. Maybe we could put an empty set like that, two brackets with nothing in it. There's no solution set, or the solution set of the system is empty. I mean, we could do the x is greater than 1. This is x is equal to 1, so we put a dotted line there for x is, because we don't want to include that. So it would be all of this stuff. But once again, there's nothing that satisfies all three of these. This area right here satisfies the bottom two. This area up here satisfies the last one and the first one. But there's nothing that satisfies both these top two. Empty set.